So hi everyone, welcome to the third class of eh, third third class of PTP for MA 2005. Today I'll be going through auxiliary view and true shape. I'll go through true shape first, but I'll show you some slides on auxiliary view first. So what is auxiliary view? Why auxiliary view? Who auxiliary view? So as you can see from this image, none of the actual views show the true shape of the surface A, B, C, D. So if you're trying to find out like the true area of it, that's a problem. So what do? You draw an auxiliary view for A, B, C, D. So it will be parallel to the surface that is involved. And yeah, one thing to take note during the for the M papers, they'll tell you the angle that they want. For example, 45, 60, or 30 degrees. Don't worry, it will be very nice angles because that's what you have. You have a 30-degree, 45-degree, and 60-degree on your triangle.
Good job.
So okay, so first step, what do? You replicate the different plane views first. So the side view, the front view, and the right side view. So as you can see, it will look something like this for this simple shape. Okay, now second step. So for example, for this shape, they want you to project along a 45-degree angle. So for the first step, you draw a 45-degree line. Okay. Next step. Okay, from FV, you transfer the vertical distance. So if you can imagine, from AB, and DC, if you view it head on from a 45-degree angle, it'll be the same length. So you can call AB, DC true length. So you can plot it there. AB, DC. Okay. A good habit is to label the different planes. So for this is XX, X, Y, X prime, Y prime, and yeah. Okay. So next step. Next step, you take your compass to transfer the true lengths of A and B. So why is AB a true length from the top view? Because if you imagine this shape here, if you look at it from the top, AB does is the true length. How do I explain this? Yeah, AB does not AB is parallel to the first one, the first front view, so it's the true length. Can you all understand why AB and CD are true length? So message. I don't understand. Oh, wait. Okay. So A, B, C, D. Okay. So you carry on. So from the datum to point A, use your compass and mark it down also. I'll upload these slides later so you can review it yourself. So you can mark C to the datum and D to the datum as well with your compass. Then you have the true shape of the inclined surface AB, DC. Then you can, following the same method, you can use it to plot the other points. AB, the top of the shape, the part that sticks out, and the part here. I will show you a 3D model of one of the M questions later, so it'll be easier for you to view. Okay. So for this chapter, there will be a lot of reference planes and datums because the views you have aren't true length. So one thing to take note, when you reflect non-true length along a datum, it will become a true length. I'll explain more later when I start drawing. shift the reference plane. So shift the reference plane to touch the line. And then you can draw. Oh, this is for another angle. Yeah. It should be, I think, 30 degrees of this plane. So you follow the same method as before, and you transfer the true lengths onto another. What? You transfer the shape to another plane. You can see here. I'll show you step by step when I draw the M questions later. Then transfer, 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 and then you have your all 5 views. Yeah. So if you all weren't sure, this is a way to draw parallel and perpendicular lines accurately. You just take your squares and draw it like that. So big set square, small set square. Oh, okay, never mind. I don't have 2 of the same lines, but if you do this and like that, every line here you draw will be parallel. Okay. So which thing? Okay, I want to touch on this true length stuff first, because it'll be more meaningful if I go through exam papers towards the end of the semester. Okay. So okay, for example, this shape 1, 2, 3. 1, 2, 3. You follow the same steps as before. Perpendicular line. This won't really I'll send you this, you can look through, but I don't think you really need these advanced steps for your M papers, as I can show you the steps to take later. It's quite complicated, but yeah, you can use it to show this. This will be the exam questions. I won't touch upon it first, but you can look through. I'll send you the slides and you can see the kind of stuff you'll be getting into. Okay, get done with slides. Okay, now time for the M papers. Okay. Okay. So let me share those. Okay. So can you all see the SolidWorks model here?
Yes, can.
Okay, okay. So if I'm not wrong, this should be your question 7, section B. I'll just show you the 3D model first, then I'll show you how to draw it after. So okay, switch again, sharing, share Windows. Okay. So okay, so we can read the question. A small bracket is shown in plane and elevation. Draw in first angle projections of the given views and project them from a first auxiliary elevation on x1, y1 and on a first auxiliary plane x2, y2. Okay. So for this, what they're asking. So they're asking, what they're asking is, okay. Can you all see the paper also?
Yes, can see.
Okay. Okay. Wait, yeah, this is not question 7, but question 8. So for question normally for M3 is the later part. What you're going to do first, you're going to draw the front and plane view first. So after you draw the front and plane view, they're all quite simple, so don't have to worry about it. Most of the time, you're just following directly what they have provided you. Okay, so okay, what does that 60-degree mean? So 60 degrees, since they draw it at the bottom side of the x square and y square line, you're going to project it here in yeah. So when you see the first angle projection, it'll look like this, and it'll be here. And if you measure it with a ruler, oh, and there you go. Okay, this is for, oh, this is 45 degree. Yeah, this is 45 degree. So this is flipped along the x1 and y1 datum. Okay. Oh, yeah. Then for the second one, the x square and y square is flipped upon this datum, and it's uh yeah. As you can see, the datum is 60 degrees from yeah, 60 degrees. Because the angle on this set square is 60 degrees. So this line is 60 degrees from the normal. So you'll be reflecting this view from here. So how you know x1 is view 1, the number 1, then x2 is number 2. Okay. So choosing where to put your datum. Okay. I'll explain with this shape, but I'll draw using question 7 for later live demonstration. Yeah. So for question 8, okay, first step after drawing your first two views, the front and plane view, elevation, yeah, front and plane view. What you want to do first is decide where your datums, where you want to place your datums. So okay, looking at the shape, it has a okay, yeah. Looking at the shape, you can see the L shape thing here. L shape. So if you want to reflect it, x1, x2 is better if it's at the bottom. Why? Because if you have some here, um, you don't really want to have anything below the datum unless it's something that's symmetrical. Yeah. So you start from the bottom of the shape. So x1 and x2. x1, no, x2 and y2, x2 and y2. So it's at the bottom of the shape. So likewise for remember how I mentioned you want the datum to be at the bottom of the shape if it's not symmetrical. Well, if your shape is symmetrical, you want it to be in the middle. Because since it's symmetrical, you can base everything about the middle line. As you can see here, both uh, before and after the datum, yeah, before and after the datum, the shape is the same. Okay, so after that, after drawing your datum, you should draw it at a reasonable distance. I can't confirm a distance with you because it depends on the shape, but I guess agak like 15 cm. Just make sure they don't intersect each other after you draw it, because yeah, it will cause problems. So draw the datum first, so you'll know the extent of the shapes. Okay. Step 2. Step 1, draw the plane. Step 2, draw the datum. Okay. So after you draw the datum, now you move on to the third step. So the third step, I'll just start with this, the symmetrical one first. Let me try to zoom in. Zoom in. Zoom in. Okay. Okay, two zoom. So now you may ask, how wide is this? Like, how wide is this shape? Well, so how wide is this shape? Like, you don't know, then yeah, okay. So imagine you're looking at this shape from the front. This will still be the length here. You all can understand why? Because if you look at here, the length of this doesn't change. Okay. Okay. So okay, we start with x1, y1. You project all the major points of interest. So as you can see here, every corner you project at a 45-degree angle towards the datum and beyond. So you know where your key features are. So for this corner, I project it all the way. This corner, project it all the way beyond here. This corner, all the way beyond. So you project every major point of interest, 45-degree, because you're projecting along the 45-degree datum. As you can see here, x1, y1. So just project. After you finish projecting, you have a lot of vertical lines, vertical parallel lines. Okay, so let's start with the top. So from the top, what's the length of this? So as you can see from this diagram, you can take the length here, mark it, take the length here, mark it. So we start from the top. We can start from the bottom side also, but to each your preference. So you mark here, here, here will match with here, here will match with here, here will match with here. Okay, so can you see this dotted line? Are you able to add this person? Wait. I'll just give a shareable link, then he can join if he wants. Let me see. Yeah. Copy link. I think if he clicks on this link, it'll work. Okay. So okay. So you from the top. Okay. So now you reach this corner and you want to draw it here. But the thing is, if you view from this, this angle, this 45-degree angle, like you see it from this 45-degree angle, you won't be able to see this corner. So you draw it as a hidden line. Yeah. Okay. Now we move on to the next feature, which is this corner. Okay, you draw here because you will be able to see it. Then this feature here. This feature here matches this feature here. Yeah, this feature here. Okay. And you just keep matching features to each other. Okay. So okay, note how this is at the bottom. It's at the bottom side. So it will match with the bottom side of here. Here. Okay. How would you know that it's at the bottom? So if you can see from the isometric drawing, how it looks like. Isometric drawing. Yeah. So this is a corner that closes in on itself. Like it closes in. I don't have the model for this, but yeah, just imagine the front closes in on itself. So this will be at the bottom of that, and it will be here. Oh, this is good. Next, I'll move on to this corner. We'll match this corner. Okay, I can see the whole thing. Then this corner will match the bottom, and finally the front will be where it stops. So the length you take from here, you're in position, you take from here. So you match this view. No, you take the key points from here, and you take the major lengths from this view. Anyone has any questions?
Okay. If we view it from 60 degrees, then we can view the true length of the right side and the true length of the bottom part.
View from 30 degrees.
60 degrees.
Okay. I'll do a representation. Okay, so for this view, this side, right? If you view from like, okay, pretend this can see. Pretend this is the camera. Okay, so for example, if you view from the top, if you view from the top, right, you'll see this exactly, right?
Yes.
If you view from the like this angle, does this like you just see this slightly more squished together, right? And this view,
Yes.
like everything's closer, but does the major lines change in dimension? Let's just say you just look down, you just like it just squishes everything together, but do all the lengths remain constant?
That part I understand. I don't understand the just now you say the last 2 points.
The
The
last
last
2
two
points.
dots. The last 2 dots.
Is it this point?
Oh, this one can understand.
Which one? This one?
That surface, yes. Why is it a
Oh,
true
where
length?
it ends? Oh,
Like this line,
okay.
that line, why is it a true length? And the surface beside it,
This
why?
line?
Yes, that
This
line.
line.
And the
Okay.
surface beside, why
This
is it like can see?
this line you just take from here. Do you understand why? Like
But
this
why
line
is it
here.
true length? Like,
Sorry?
why is it true length?
Oh, why is it true length? Like, for example, this length is 25, but this length is also 25. You don't understand why. This length and
Because I thought we view from an angle, so should be slanted length. Is it?
no, but you're viewing it from the front, so it's bit
Okay.
like how to say? Because when you see the octopus, so when you view from this angle, the 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 width of the object doesn't change no matter you go from here or here. Do I have anything to go? Okay. You see this pair of Uno cards. So if you view it at a steeper angle, does the width change of the Uno cards? No, right? Like this is still as thick, right?
Yes.
So no matter how like yeah, so that's the same principle. No matter what angle you look at it, the width does not change. Okay?
Can.
Okay. Okay. So now we move on to what I think is the harder one. So this view. So you're not like taking from any flat plane or anything. You're taking from a weird ass 60-degree angle. So this 60-degree angle. So by now you should have already drawn your datum. Okay. So next step. So you done step one. Step one, draw datum. Step two, mark out all the key points of interest, all the parallel lines. So parallel line, here got one intersection point, so parallel line, here parallel line, parallel line. After you draw finish all your parallel lines, okay, then you can move on to the next step, taking the true length true length. Okay, now what is a true length? So if you can imagine, this is the top view and you're here. Then you look at it from this angle. What stays the same? What stays the same is the height. The height doesn't change because you're looking from here. Does the height change even if you look from any angle? No. So you can mark out the height first. So this is 15 cm. 15 cm. So you can just mark out all the heights. Like for example, the front of this shape, you can transfer to here. This length, transfer to here. And yeah, that is the first step. Now you may ask, how do you know how long this shape is? Well, okay, after you have drawn all the vertical lines already, right? Yeah, all the vertical lines, you can start matching them together. So, okay, you see here. Okay. So one important thing, you know the height of this. Okay, I'll explain how to do zoom in. Zoom more. Okay. Okay, this should be a part that confuses a lot of people. Okay, so for this part, how should you know when it ends? So where does it end? Okay. Okay. So where does it end? So what does this part correspond to? This part corresponds to this, which also corresponds to this. So what you do? You take the height. You can plot it here. It will be the same height. So in this case, height is around this length, and I plot it here. Okay. So you know this part is connected to this part, as you can see from here. So this part, join it here. Understand? And you continue to replicate it for all the other sides. Okay. Okay, if y'all don't have any questions, I'll start on question 7 of M3. And y'all can follow along if y'all want. But I recommend y'all follow along because it will help a lot. Let me share the cat also. Refer to your question 7 yourself because I'll show you the cat as I draw, and that should be easier for your cat. Can you see the cat clearly?
Yes.
It's not. Is it blocked by anything?
No, it's okay.
Okay. So first step, just draw the two views. So I'll draw it quickly, but you should follow exactly. Okay. So as usual, draw the construction lines first. If you're watching the video, just slow it down, then you can follow along in the future. So you just construction line, then 12 plus, and move it 76 inches. You can see. Okay, zoom out. Okay, and 76 inches. So 88. Okay, that's the most of the horizontal. Wait, no, there's still one more 24. 24. More the line. Oh, did someone say something? Check. Are you able to add? Okay. I on click on wait, can zoom a bit. Click on the other screen. Oh wait, spotlight me. Can you see the drawing video now? Is it okay now? Oh yes, yes, okay. Sorry. So okay, now I got the major vertical lines already. Now I draw the horizontal lines. Okay. So base, then move by 76, 76, 76, and I'll just leave a space of 2.5 cm. I move up by 24. So 20, 24. And move up by 76. 76. Oh shit, that's a bit too long. Fix that. Okay, so this is the basic. Let me just fill it in now. So, okay, so do I draw one line? Celsius. For the okay, this should be correct. Well, yeah. So this is the right side view and now the top view. The top view is essentially Okay, it's not a square, but a rectangle. 6. 8. Okay, then the middle is 6. 38. So draw a center line 38 mm from the bottom. Wait, 38. 38 minus 6, 32. So 32. This is a bit of math. Okay, 32. Okay, and then now, okay, from the top. 32. 1, 2, 3, 32. Okay. Okay. Okay, so this is how the shape looks like from the top. Okay. So now let me draw my 60-degree data. So how you draw the 60-degree data? Since this angle is 60 degree, if you all didn't know already, let's put another projector here. And okay. Okay, how far do I want it? See from there. With this width, so around here should be fine. We draw data. 1, 2, 3. Okay, so this data will be for this shape. So, oh, okay, it's too short. Okay, needs to stretch at least from here to here. I'm just going to use a construction editor first. Okay. Now for this one, a 45 degree. So for the 45 degree, okay, let's see. Okay. Right here. Okay. So this shall be the 60 degree, 60 degree, 45 degree. Okay. Okay. Now what do we do next? Step 2. You draw all the you project all the key features. Okay. Mm, Okay, all the key points. Just lengthen this because they are too short right now. Lengthen. Outlines. Okay. Now, okay, I've done projected all the lines. Okay, as you can notice, for this shape, it's symmetrical down the middle. So what do you want to do? Okay, let me just tuck in the dotted lines first. Okay, and this is phi2, x2. So since the shape it's symmetrical down the center line, I'll draw it hit a lot. I'll draw it half half. So this datum will be right down the middle of the shape. Okay. So let's start with the top. Let's start with the top first. So the top, what's the length of the top? The length of the top is 76 mm. So let me mark it out using the ruler. Okay. So okay. So 76 is 3.8. 3.8 to 3.8 on both sides. Okay, first. You also can use a compass if you like. 1, 2, 3, and then draw a center line through this.
Let's work.
Yes. Hello? Hey. Okay. Draw a center line through here first. Okay. So one thing you can do, you can take this, put it on center line, and you can mark it down also. So mark and mark. So you can do it two ways. So let me, okay. And okay, this will be the top of the shape. Yeah. Okay. Now I move on to the next line. This one. It's also the same length as this. So one thing you can do is just draw it straight down. Yeah. Draw it straight down. So you want to make sure everything is. I put a set square on the edge first. Then I put my set square against it. Then I can remove my set square. Then I can be sure that the angle I'm doing at is around it's at 60 degrees. So let me just connect them together. Okay, so I got the second point of it, this point. Okay, now let's move on to the next feature, which is right here. Okay. So if you weren't aware already, from the isometric drawing, I will go to CAD. Let's see if I can switch views. Wrong. Okay. Can you all see the cat now? Let me get to the correct view first. Label hidden lines. Okay. So, can you see the cat? Okay. Can okay. So this is how the shit looks like. So if you were to look at it from this angle, this will kind of be what you see. Yeah. So as you can see for this portion, this the the mid section of the L, yeah, mid section of the L. If you view from this angle, if you view from this angle, this mid section of the L is still the same width as the top. And to be honest, from the top till the end, it's all one straight line of the same length, because you're just viewing it from the front, directly front. So the width throughout the front is the same. Okay, I'll go back to the drawing. So if you can visualize that now, I will just, okay, I'll just take this. Okay. And go straight down all the way. Straight down, and I can close the box. Because this is the front edge, which is related to this side, which is the entire front. So I can close it. Okay, so this is how the shape looks like from the front, the outline. Okay, let me go fill in the hidden lines and such. Okay, so continue from top again. The second line. We'll touch the rib later, but okay, let's go to here. No, actually, no. This part will get intersected by the support, so I'll leave it till later. So let's go to the front of the object. So the front of the object is related to this line. So I'll draw one across. Okay, the next line. This is a hidden corner that is covered by the front. If you look from here, if you look from here, you won't be able to see this corner. So it's a dotted line. Okay, then I move on to the next one. This is also a hidden corner, so it's a dotted line as well. Okay, then I move on to the next one. Hidden line again, as you can't see it, because it's blocked by the entire front. So dotted line. Okay, then this one. Okay, now let's move on to the rib. So for the rib, the width is 12. Okay, so you know that the width of the rib is 12. So you can just mark it. You can use the protractor, use this to measure. I can just mark 6, 6, and extend it all the way down. Okay, then I shall darken the line. Okay, so now that I darken the lines of the rib, let me draw in this corner. Okay, so here to here, here to here. Okay, so this is how the view looks like. With all the hidden lines, center line, and stuff. Okay. Now I'll move on to this shape. Yes. Hello. Diane, you have a question? I just meet you first, Okay. 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 Mm. Okay. I think I may have fucked up a bit. Messed up, sorry. I drew this a bit too. This I drew a bit too close. So now you see my mistake. Don't replicate it. It was just to test your. Now you can learn from my mistake and draw this view further away. Okay. So you can see here. Let me just extend all the lines through. If I agree. Just nice. These two should be near each other. Okay. Don't worry if your construction lines cross the other shape, because it's quite normal. Okay. So it looks like this. Ah. So I think, okay, I made a mistake. It's too close. I will draw over it, but try to leave like more space between your shapes. So further like 15 cm gap, because yeah, if you draw too close, they'll intersect. Okay. So now first step. Okay. So imagine you're seeing it. Okay, I'll switch back to the cat. And the spotlight. Spotlight. Okay. So let me enter the cat. Okay. So what you see here, you all can see the cat, right? Yeah, if you can't see, just say no. Then what you see here, you're looking at it from a 45-degree angle from the side. So at a 45-degree angle, all the heights are still the same, as you can see. Because when even if you rotate it, all the heights remain the same. So the plate will be still 12 mm thick, the height will still be 88 tall. So yeah. Okay, let me switch back to the paper. Export. Okay. So as you can see from here, I'll start from the bottom of the shape. Okay. So where is the bottom of the shape? The bottom of the shape will start from here, and it will end around it will end at this point. So the bottom of the shape will be from here to here. So let me draw it in first. I will overlap it, but during your actual drawing, don't try not. So let me just erase this first. So it's not overlap. Lines again. Okay. So you start from this corner, which correlates to here. Uh, this corner will correlate to this corner, and this corner, here, will correlate to this corner. So I'll just draw it in first. Because if you see it from if you see it if you see it from a 0.5-degree angle, this will be the extreme right of this view, and this will be the extreme left of this view. So let me just fill it in first. To be honest, you can start wherever you want, but I like starting from the bottom because it's nearer to the data that you're going to draw. And since it's not symmetrical, you can't start from the midpoint. Take that into consideration. So this is the bottom of the shape. So okay, bottom of the shape. Now the height will be the same height. So measure the height. Actually, let me use the compass. So you can use your compass as well to measure the height. Okay. And you just go here. Just mark it and put your compass down. Mark it. And this height will be the same as this height. Just draw. Okay, good. Now this is the entire right side of the shape. Okay, so the next step is the top of the shape. The top of the shape, the 45-degree. It extends from here to here. Because even if you view it from this angle, this top is still flat. Now let's move on to this height. Okay, so this height is 24. Let's use the compass. Okay, so this corner will correspond to this corner. Oh, did not mark it down. To mark it down. Okay. Apologies, I forgot to mark in this key corners as well. It should be a dotted line. Okay. So you got this key corner here, which links up with this key corner. So take your compass, measure this, so this, and this will link to here. And you can mark your 24. This is 24. And yeah, you can stretch it up. Stretch it. Okay. Now the next line will be here, which is also 24. Use it to mark it. And I'll extend. So these two lines should be parallel to each other. You can check. They'll be the same. So this length, same as this length. Okay. And there'll be nothing here. So fill in the dotted line so it's clear for y'all. Okay. So this dotted line is x1, y1. No, x bar and y. What I think. So what now? For actually this this corner corresponds to this corner. So let me just show you. Oh. Should extend all the way to the end. Yeah. Okay. This one corresponds to here. Two. Yeah, draw it out. So this is the bottom of the shape. You can see it. Okay. Now the next part. This gap here. So this is 12. 12. Where does it end? It ends here. And this will correspond to this corner, which corresponds to this line here. Okay. This line here. But since I don't have anything, you can draw it from the next line over. And I'll just extend this line all the way across. Okay. I can make sure you measure it's 12 mm all the way through. Across the front. Okay. So this is the shape. If you see the SolidWorks, yeah, it's this portion. So I finished the bottom portion. Oh wait, there's still one more line. So okay, I'll get to the line now. Okay. So for the line, what is the line? The line is this corner here. This corner coincides with this corner, which coincides with a corner here. So from here, go all the way up here. Then you mark here. Good. Okay. Now what's next? Next step, you fill in the ribs. So the ribs, you can just mark where they start from first. They start from here, and where do they end? They end somewhere here. Oh, let me fill in the top first. So how you fill in the top? So this line is height here. So I'm just gonna this will correspond to shit seeded the people a bit tiny. Okay. So this corner coincides with this corner, and this corner will go up. Let's draw it here. Don't worry about the limits. Because your tutor will give you exactly where he wants the starting point, so you won't exceed. Yeah. During the exam, they also draw the datums for you, so you also won't exceed the paper. Yeah. So okay, let me just draw it through. Oh, so this coincides with the top of the shape. You can see here, top flat. Okay, so the start of the ribs will be here and here. So what I can do now, I can connect the ribs together like this. So from here, the left side of the rib, connect it down, and the right side of the rib, I connect it down. Okay. So what's next? What's left? Okay, what's left? This line here coincides with this line here, which coincides with this line here. So let me keep it. Okay, so fill it in. What's left is, okay, if you look from the side here, you'll see a corner caused by the rib and the back plate of the object. So I'll fill it in. Okay, so this should be the final shape of the view. This will be how your view looks like. Oh, yeah, this will be how your view looks like for the 45-degree. Oh wait, there's still hidden lines. So this line here, okay, this hidden line here. And the other hidden line here. It actually extends from the top to the bottom. So. Yeah. So this will be how the shape looks like. Yeah. Any questions? So to summarize, the first step you do is to draw your. The first step you do is to draw both your plane views. Second step you do, draw your datums. Third step, project all the key features over. Fourth step. So fourth step, you take your real length your dimensions from the other drawing and you project them to the other one. So for example, x2, y2 is the view for this. You take the length from here. For this, you project it here. Take the length from the other view first. Then you start drawing. Okay, anyone got any questions before I move on to true line, true shape? The weird looking triangle thing. Just write it down somewhere. Oh, the two views. To your datum we project figures for take dimensions on other where good. Let's okay. So 4 steps. Everyone clear? Okay, if everyone no response, I'll just continue to the next Next one. Okay. So the next one we are doing is true length and true shape. So, okay. May I all refer you to question 3. Okay, we do question 3 because it's one of the harder ones, and if you do question 3, you can like get the basics already for the rest. So, what do you want to do for the first half of N3? So it may be confusing if you look at it, but essentially what they want you to do is this. Exit spotlight. Change. Okay. What they want you to do is find out the true shape of this triangle here. So how are you going to do that? So the way I do it is to project, get views from this angle, and this angle, and from top down. So what does it look like from here? Pretend there's a shadow behind it. So there's a green. So for the elevation, pretend there's a green shadow here. Then for this side, pretend there's a red shadow here. Different shadow. Red shadow. Then from the top, black. Oh, the regular black shadow. Black shadow. Okay, black shadow. Okay, so what you want to do here is draw the green shadow, the red shadow, and the black shadow, and you get a view of the paper. Okay. So, okay. So for that question, right? Okay. The first thing you do is to draw the XY axis. So you draw a very long X and Y axis. This axis and this axis. Okay, so everything begins from here. Okay. So, okay, from the picture, what are some things that you can confirm? Okay, you can confirm that from the elevation view that you're looking at, question 3, point C is 40 mm away from the right side of the page and 0 mm from the bottom. So what do you want to do here? The first thing you can do is to mark up the points that have been given values. So C is 40 mm away, so you okay, mark it. 1, 2, 3, 4, 40 mm. The next value you have is 65 for B. B is touching the right side and it is 65 mm away from the bottom. So 65 mm. 1, 2, 3, 4, 5, 6. 65 mm. Okay. If you're confident follow on to here, you're doing great for this. Because this is a hard question that you won't encounter during exams again. Message. Sorry. Okay. I just watched the video. Okay. So point B and point C. You mark those down first. Point B, point C. Oh. Okay. So this is your BC line. Okay. What is the next step? So the next value you're given is that AC or angle ACB is 30 degrees. So 30 degrees. Where can you get 30 degrees from? can get 30 degrees from your set square. So let me mark out the 30 degrees with the set square. Oh, okay. Mark out 30 degrees. I don't know how long the line AC is first, so I'll just mark out a line first. Okay. So 30 degrees. Okay. Right now. I'll message something. Okay. 30 degrees. Okay. Okay, I'll move on to another view first. So you can see that C is 25 away from the left wall. So I'll mark it down also. C is 25 away from the left wall. 25. Okay. B is here. Then B is 25 away from the left wall also. So from this height here, I'll mark that. I'll mark it straight across. And since C and B are the same length away from C and B are the same length away from the left side of the shape, you can assume that C and B is a vertical line from if you look at it from the elevation view. No, from the right side shadow of CB is flat. Yeah, it's straight. So you can draw it like that. This B. Okay. Now the next step, what you want to do is okay. The next thing you know is ABC is 90 degrees. So where you can find 90? Set square. So your set square just the 90 degrees side. Okay. So with your set square, just draw a line. Yeah. Okay. So this is 90 degree. This is 30 degree. And technically this is your A already. So this is technically the true shape of the thing. Yay! No, we're not done yet. We still have to draw the side view and the bottom view for this shape. Okay, so how do you know how tall the thing is? Okay. So what you can do here is so what you can do here, take the vertical. And just project it across. Okay. As you can see from the shape, as you can see from the drawing, A is touching the left wall. So the A is here. And this is the height of the A. Instead of A, you can draw C also. And this is your right side view. Now for the bottom view. Okay, so for the bottom view, C is 25 away from the base. So we should draw 25 construction line. Yeah. Right. 25. So C is drawn number. C then yeah. Oh, okay. Yeah. It's not the true shape. Okay. Yes. Let me erase some lines. Okay. Okay, apologies, I made a mistake for this. But, okay. So no, you still draw the 30 degrees. You still draw the 90 degrees. But the thing is, this is not your true A. Because this is just your projected A. Yeah, this is not a true A. It's your projected A. You need to find the true A. True A is somewhere around here. Okay. Now, how to find your true A? Okay, this topic is a bit hard to explain through the camera. You can ask your prof more directly, but yeah, what you want to do for the next step, draw a line here, and one more line, if I end them away. Okay, now these two lines, I'll label them B and B prime. B and B prime. Okay. So what you want to do here? Take your compass. Okay. Now that you have this line, take your compass, put it between the lines, and you mark it here. Okay. Mark it here. Now you take your compass and mark here, and mark accordingly. So you see here. Yeah. This will be your true A. This will be your projected A. Yeah, it's true shit. Yeah, this will be how the shape looks like on the right side plane, and the slightly bigger one will be the true shape. Correct. So since this is the view from the right side, on the right side, you can project your A to the other side. You project your A to the other side, and you can draw here. Okay. Now this is your actual A, the projected A. You can see. Then you drag the A down. Drag it down. You can draw the A. And lastly, C. The C, sorry, C, B, A, C. Okay. So this is the base view. This is the right side view, and this is the left side view. Wait. This is the right side view, left. Oh. It's the left side view. View is B. Side view, right side view, and the bottom view. Okay. So if you don't believe for this side, you also can prove it with this one. So as you can see C here. So B, B, and C. C to A. So mark it down. And as you can see, this length that I measured here, the same as this length. You can mark it too. So this length corresponds to this length, and this length corresponds to this length. Okay. I feel that there will be a few questions, so ask away.
Jenny, I
Oh,
think your
Oh, the screen
froze.
froze.
Yeah.
Oh shit. How long already?
It's been I think a minute plus or something, but
Shit.
yeah, it's frozen.
Oh shit. I think my phone died. Yeah. Damn it. Eh. Oh shit, my phone died. Okay, wait. Let me improvise right now. Shit, not gonna be. Let me improvise. Give me a while. Give me a sec. Can you see my OneNote? Let me do in the spotlight. Okay. Can you see my OneNote? Okay. So, let me draw the 3 triangles again. Okay. It's a thing of them. Okay. So C, and this will be C prime. And A, so A prime. Then this one dot dot dot. This will be B prime. Okay. So now the question is, okay. I'll take a photo, then I'll upload it into the PTP group. I'll use it as reference. Let's use it as the reference. I'll upload it. Okay, never mind. Okay. Remember how I drew the three triangles? Okay. So the first step, okay, I draw the true shape of it first. So true shape of it first. So this is 90 degrees, then 30 degrees. Now the tricky part was to find out how do I find the A projected. But it's true A, so I wanted to find A projected. How do I do so? Okay. So what you want to do? Okay. So A projected. But the thing is you don't know where A projected lands. But the thing you know is B and B projected. B and B projected, as you can see here. Okay. Have a length of 25 mm away from each other. B and B projected. Okay, so B and B projected have a length of 25. So 25. Okay, A, B. So A and B projected. Okay, so what you want to do is take AB, the length of AB. You measure AB with your protractor and you plot it here. And you have this length. So now what is this length? This length is the length of this length. These two lengths are the same. Meanwhile, this length same as this length. Understand? Hello? Oh, okay, yeah, okay. Okay, if you're having a hard time imagine you're looking at it from the top. So A, then this is B, then this is B prime. So A to B will project along here. So you get the A to B prime length. A to, okay. Yeah. Okay. Yeah. So A. So when you do it here, it's the same. So, yeah. Okay. So when you project, how to say? Okay. So this is true length, and this is also a true length. So when you want to know how long A bar to B is, you can use this method. Everyone okay? Okay. So yeah, that'd be all. This will probably be the hardest question you can do for this will probably be the hardest question that you'll be doing for the M3, because M3 first part, because there's all three corners are touching the corners. Meanwhile, this, right, you have AC that is flat, so it will be a lot easier than this. Okay, so okay, I shall move on to the. Okay, I'll upload the picture first. Okay. In the meantime, you can ask questions. Still frozen, but then. Okay, if there's no questions, y'all can message me directly on your free time. Yeah. So if there's no questions, bye. Okay.